Hi everybody, Beat Zimmermann here. This is the live footage of the webinar about transitions that we held on June 4th together with the partner company Procedure Validation Solutions. The main speaker was Josef Anschau, a senior captain on Airbus 330 and 340 and a certified flight validation pilot. I hope you like it.
Okay, hello world. Welcome to the second webinar that we decided to offer to the community. The last one was about PBN naming and charting. This is available as a film in the ANI YouTube channel for those who have missed it. And this time we decided to cooperate between myself and Josef and the company Procedure Validation Solutions. It's a partner company of mine. Some of you have already experienced their high-level training in Frankfurt. They are part of the ANI instruction team and is a company that's specialized in flight validation. But also they are on the side, they are maybe not on the side, but as part of their life, they are all airline pilots. So I will just do the introduction and I will hand over to Josef, who's a senior captain on Airbus 350 and what else?
350 no longer, 330, 340.
Okay, you're 350 rated as well, right?
Yes, I am, yeah.
He will actually play the game with you. I will just do the introduction. The reason why we chose transitions is because we get a lot of questions about transitions. If people go into the ICAO document framework, you will not find the term because transitions are not an ICAO concept. So many people are a bit confused of what a transition means and what it could be. In my introduction, I'll just tell you it can be pretty much everything from a procedure design point of view. I'll show you an example. This is a chart of an approach where the approach is an RNAV, or today it would be called RMP to runway 14. There is an airway coming on top of that airport, something like this. The procedure needs to be able to be joined from the west and from the east for various reasons. And in this regard, here we have a transition and here we have a transition. To use that concept gives you a couple of advantages. Number one is for ATC clearances. You can clear the RMP 14 approach via ROTOS transition or via Telmo transition. So it's an ATM facilitation concept in a way, but also from a procedure design aspect, it means for a transition, you can have any combination of non-common things in the procedure. So what is common between the west transition and the east transition is obviously the final approach here and the missed approach plus the hold. So that's the common part. What's not common is the intermediate on both sides, which is 30 degrees offset, and then the initial, which is this part. On both transitions, you have an initial approach fix, and then you have an initial approach until here. From the ROTOS transition, you have an initial approach from here on the Telno transition, and then you have two intermediate approaches, and then you have a common final approach and a common missed approach. This is one example. There are several other examples. There could also be a common part, final approach plus intermediate approach, and then the transition would be initial approach only. There is also the possibility that the whole transition also includes a standard arrival route part or an arrival segment part. So there are all kinds of combinations possible. It hasn't got a clear meaning what a transition is. And this is what we're trying to highlight, where it's coming from. I think this sets the stage for you, right, Josef?
Yeah, what you see here is the most, or the oldest way of having a transition. It's actually an approach transition, right, which has been in use, but not named like in this kind. This way, it is named a transition, but we have had approach transitions since years, but nobody called it approach transitions. It's just one final approach from different initial approach fixes common. Here's one example where it is actually named a transition. I have many examples where it is not called a transition, but actually it is one. But there's more besides an approach transition. There is more ways to have transitions. And we're coming into this, a little etiquette. I think everyone has muted its microphone. This does not mean you can't speak or you can't jump in. You just have to unmute shortly, say your name, speak, and when you're finished, just mute your microphone again. For those who want to have a look at it, or for those who couldn't join, It is again posted on YouTube by Beat after we're done. Let's jump into things. Transitions. They have advantages. They might have disadvantages, but basically what they do is, especially in very complex situations, they increase the clarity, simplicity, unambiguity, and the safety. This is what we think. But there are some requirements, or at least there could be some requirements in terms of what airspace am I working in, and is the design I'm looking at capable or suitable for transitions, and maybe there is a requirement to adopt the design or even redesign things to make the system compatible with transitions. We come to this later when we're through examples, but to start with, what are these so-called transitions? They are by no means mentioned in ICAO. This is what Beat said already. It is not mentioned in PANSOPs or anywhere else. And if you dig up the tabular description of an SID in PANSOPs, it does not show the transition. It shows an SID, but there is no mentioning of a transition in ICAO. So what are transitions? If you look at this picture, you could see whatever you want to see. I'm an old man. I see like dolphins, 10 dolphins I can see, but you might see whatever else. And if you look at the right picture, you could see SIDs. How many SIDs would you see if you look at this picture? Any ideas? Anyone? Yeah, Peter.
I would say I see 4 SIDs here.
Okay. Any other options? Well, you could say there's one.
I join on 4.
4, yeah. We could say we could have one from here to there, to there, to there, to there, to there. This would be 1, and then 1 to there. So we have 2 SIDs from runway 27, one leading to Walter, one leading to Darren. And the other way around, we could have, again, 2 that come like this from runway 09, and they lead as well to Walter and to Darren. So it's in total 4. This is what we thought as well. Number of SIDs without transition would be 4. 2 from each runway, which is the usual way you design an SID. And this is the way it is in most places in the world, which leads to, if it's complex, many data and many SIDs. To save some space in the FMS, or to make it easier to understand, or to give a better overview in charting and in the FMS data, you could also say it's one SID with transitions. The SID, in this case, would be just this short part, just from CODA to RALS. This is the SID. Everything else is part of the SID, but it's not the common part. This here, the green line, is the common part. The non-common part is a runway transition starting from runway 27 to CODA. Then you have the common part, and then you have en route transitions from RALS to either Walter or Darren. So you save a lot of space and you declutter the map. So with transitions, you would have 2 runway transitions, one from 09 to CODA and one from 27 to CODA. Then you have a common SID, and then you have the en route transitions from RALS to either Walter or Darren. How would this look like in an FMS? And how would this be clear to an aircrew? So if you look at the screenshot to the left, you can see how you would work the FMS to get this in. You get a clearance. PDS 1 cleared to Zurich, for example. Runway 09, which states the runway position. RALS 1 Alpha, Darren. So this defines first the runway transition with the term runway 09, then the common SID, it's the RALS 1 Alpha, and the en route transition, which would be Darren. Flight level 110 and the squawk. So what would you do with this clearance in the FMS? You would start selecting a runway, which defines the runway transition, in this case 09, which means you're starting here. Which means as well, it is the only way to get to CODA is the red line. So we have a definition for runway transition from runway 09 to CODA. Then you say it's the RALS 1 Alpha, which defines the common SID, which is this one. And then you select the en route transition, which can be either Darren or Walter. In this case, you would select Darren. That's it, done. How would this entire thing look like in ARINC and the coding in the FMS? Here you can see the same procedure and some simplified, it's not the entire ARINC coding, just to give you an idea how this would look like in a coding table for the data house. Here, starting on top, you have the runway transitions. It starts at the runway 09, Joplin, Allen, and so on to CODAP. Then you have the same for the 27, ending at CODAP as well. Then you have the common SID, which is the green line you can see between CODAP and Rawls. And then you have the en route transitions from Rawls to either Darren or Walter. What you have to see is here, you don't repeat like you would do in all 4 SIDs. You don't repeat the entire thing for each and every SID. The only thing that you do is you have one common, this is just 2 points, and then you have the transitions leading to or from the common point to en route. Saves some space and makes it easier to understand for those who work with it. It's not only the pilots working with it, it's the controllers too. Let's look at the same situation regarding stars, because it's the same concept you have here. We just turned it around. We now have stars, which could be 4 stars without the transition. It would be a star from Darren to runway 09, from Walter to 09, Darren to 7, Walter to 7. Using transitions, you have again only one common star, which you can see here. It's the green part here. This is the star. And you have an en route transition from either Walter or Darren. And then you have runway transitions depending on the landing runway in use, the red lines, going to either Allen or Jersey. You have a view towards the FMS. How would you select it? You get the clearance. Clearance would be ANI 2 cleared via Walter, which gives you the idea of the en route transition. So it starts at Walter. Rawls 3 Echo, which is the common part. Then the vertical clearance, descent flight level 70, expect RMP runway 27, which gives you the runway transition. In this case, this one. So you start selecting the approach and the runway. Then you select the star, and then you select the en route transition. And then in the end, it looks like it would be just one star. This is again an example of a coding table. How would you split the 4 stars into a common star and the en route and runway transitions? And it's the same as it was in SIDs. You have the common, this is the common part again, and this is the coding of the common part. And then you have the en route transitions, either Walter or Darren, and then you have the runway transitions, either Allen or Jersey. There's more. It's not just the stars and the SIDs and the common en route and runway transitions. There's also a concept of approach transitions. We've seen in approach transitions, Beat showed one. Approach transitions have been in use for years, but nobody called it approach transitions. For a good reason, because they're not mentioned in ICAO. Even the examples you can find, the tabular description of approach in 8168 doesn't show an example of transition. You already have, of course, multiple IAFs that lead to one approach. And the connection between each initial approach fix to a final approach fix or point actually is a transition, an approach transition. Whether you call it an approach transition or not doesn't matter, it is actually one. How you would code this can be different. If you look at this, you could have, like in this example, if you have such a case like 2 initial approach fixes here in this example, Kleber and Rick, you could have 2 approaches with one common final approach and missed approach. You could also have just one final approach and missed approach and approach transitions. An approach transition is actually just the connection between the initial approach fix and the initial fix or final approach fix. In this case, what you see here is the transition, the approach transition for the final approach from the initial approach fix Kleber and the one from Rick. So you have 2 approach transitions and 1 approach and missed approach. Looking at the FMS first. It's the same concept as we have seen before. You select an approach and you select the approach transition. This is not exclusive. You can have stars with en route, common and runway transition, and additionally approach transitions, but you don't have to. The clearance for such would be PVS1 cleared by a Kleber RMP runway 09 right. There could be more before this. There could be a star with transitions too. In ARINC 424, there are route types that allow just this. Here you see how an approach transition would be coded. So you have down here, you see, this is the approach and missed approach. It starts from the IF intermediate fix Laycop, it goes to the runway and to the missed approach. So leading to Laycop, you have just two variants, the approach transition via RIC and the approach transition via Cleaver. Makes it easier for controllers and pilots, saves some space. To wrap it up, in SIDs, you can have a runway transition, you must have a common SID, and you can have an en route transition. Charlie.
Thanks, Joseph. I was just going to let you get to the end, but I'll ask my question now. How does that rate then with the actual ability to publish the procedure in accordance with Annex 11, Appendix 1 and Appendix 3, specifically Appendix 3 in this case?
This is a contradiction. We have an example, I have it at the very end of the presentation, where just this led to a more complex situation than it has been before. Because if you follow this rule, you will have to have a publication that again shows all SIDS or stars or whatever you have separately. So the concept of transitions is not part of the publication standard. If you go strictly by the publication standard, you would again have the necessity to publish separate SIDS and separate stars, one after the other. But this makes the system very complicated, as you will see later. We're trying to promote to do it differently.
My apologies. I get the concept, and I fully understand the opportunities that you have in terms of the coding.
Yeah.
The issue, as I see it, it's 180 opposed to what is currently in Appendix 3 of Annex 11.
Absolutely, you're absolutely right. But we are promoting to have this changed, and we are promoting to allow publication and coding. The coding already takes place, at least partly takes place, to save space in the FMS database. What we are promoting is to allow the publication of transitions according to ICAO, which we have not at the present. We must have the common part of stars and SIDS, and of course in an approach we must have an approach. There is no actual need to have an approach transition, but you can have one, and it makes things easier. And it's the same for stars and SIDS. You can have the runway and the route transitions, but you don't have to. What you must have is the common part. We have some misconceptions. We have some irritations about what are transitions and what are transitions not. There is a conception that a transition is always an RNAV transition, and there is no such thing as an RNAV transition within ICAO or elsewhere. You can have, as I said, you have stars and SIDS and approaches, and you can have en route, runway, and approach transitions. And whether they are RNAV or not, and whether they are RNP or not, or whether they are conventional or not, depends on the type of approach, star, or SID you're dealing with. So whether a transition is an RNAV transition, an RNP transition, or conventional depends on the star, SID, and approach you're talking of. So they are not always RNAV transitions, and actually there is the term RNAV transitions is widely used, but there is no such thing at all. There's a conception that they have to be published on a separate chart. Yes, you can, but there's no requirement to do such. You can have it on the chart of an SID, of a star, and usually you have it on the chart of an approach. There is a conception as well that it overcomplicates the daily operation, which is in our perspective, in our point of view, not the case. It can actually declutter the charts. It can make the overview better. It can increase safety by doing this. And if you do it right, if you implement it correctly, it can ease operations for both sides, for the ATCO and for the pilot. And it also can decrease the workload for the ANSP in terms of amending AIP, of changing parts of the procedure. There is a conception that it is an industry standard and shouldn't be mentioned in PANSOPS or PANS-ATM. And I think this is wrong. I think they should be mentioned, and there should be a standard to increase safety on these procedures. We have been running into problems in terms of approach transitions that have their own 7-digit designators. Like you know from stars and SID, like example ROLS 1 alpha, ROLS 7 echo, or 3 echo. If you use this on an approach transition as well, it gets complicated because you can't define this. This is not RNA definable. You can't have like a ROLS 1 alpha star with transitions and an approach transition that has a different name after the star. You can't combine these. What an approach transition is always a via, does not have its own 7-digit designator. So I hope I could make myself clear. The approach transition is just the connection between any IAF to a common IF or final approach cause fix or final approach fix. And it has to be designated as a via and not as a 7-digit designator. Advantages, disadvantages. The group might come up with more. This is what we thought of and we just wrote it down, but we can discuss this later. For the cockpit crew, it increases simplicity. During preparation of the FMS, it makes the chart easier to interpret. It's a new, but it's a less complicated concept for ATC. The chance for human error is less, and therefore the safety is increased. Transitions use less data in the NAV database, and the advantage of using less data is you can have all procedures in the NAV database. I don't know whether you know it or not. The number of SIDs and stars on one airport is limited in an FMS to about 70. But we have airports where you have up to 170 SIDs and about the same number of stars. The data houses and the airlines have to cut down the number of stars and SIDs contained in the database just because of this limitation. In total, most of the FMSs you use in an airline operation are limited in data capacity. The more procedures you put in there, the more waypoints you put in there and repeat them maybe, the sooner the database is full. And then you have again the necessity to choose which part of the navigation data is shown to the pilot and which part of the navigation data is scratched out just to avoid oversight.
Joseph, I have a provocative question. If we did not have any database limitation at all, if there was not a problem, do you think we would still talk about this concept, or would we just code SID by SID and approach by approach?
I would still promote transitions because it makes it easier to understand and to interpret a chart or to work with your FMS. I still would promote transitions, but if you look at our present state of our FMSs, this is one more advantage which we can circumnavigate a restriction. This is unnecessary. I don't like the fact that our FMSs have such strict limitations in number of waypoints, in number of procedures per airport. I don't like this. This is one way to work it around.
Yeah, I mean, the memory limitation is a different story and it's ridiculous. I mean, every Apple Watch has more memory.
That's right. And as said before, besides other reasons, one big issue is that the charts are less cluttered. The overview of the charts is better. And the AIP revision is easier. If you change a little thing, because you have to, in an AIP revision, you would have to change hundreds of stars and SIDs maybe. And if you have transitions, you just change one common and leave the rest alone. Disadvantages, and this is a big thing, there is no guidance material in PANSOPS and PANS ATM. We have publication issues. We have unclarity by the ANSPs and CAAs and by the procedure designers because the guidance material is missing. Let's have a look at an example of SIDs. This is Atlanta. And as you can see, we're looking at a system of 5 runways. We would have just to the 1 point cut-in here, conventionally published and coded 10 SIDs. Now, using transitions, you have 1 SID with 5 runway transitions going east and 5 going west, and 1 en route transition from Cotton further on to Hancock. Saves some space and easy for the pilot and for the controller to work with the system. You change runways short term, you just change the runway transition, which gives you another route, but the name of the SID and the common point of the SID is still Cotton. A lot easier. Same airport, Atlanta. The other way around, it's stars. So you have here, you have the Hobbit. As you can see, they are fans of Lord of the Rings. There's all Lord of the Rings names. So you have the common star is the Hobbit 2, which is here, from here to there. And after the common part, there's runway transitions, one leading north and downwind, the other one leading to southern downwind. And before all this, there's the en route transitions from several points all over the chart. But still, it's the Hobbit 2 arrival from different points leading to all possible runways. Very nice and simple concept. Here you have an example of an approach transition. This is Denver, Colorado. So you have several IAFs that lead to one initial fix with this color. This one here, as you can see, is the IF. Merkel is the FUF. And then you have the IAFs, Ledora, Boss, Teller. Instead of coding again and again and again the same final approach and missed approach, you have transitions to color from different IAFs. That's it. But I promised you, I show you an example. Here you see in El Salvador, they used to have transitions. They used to have a star from Yankee Bravo Victor, I think it is, this fix in the middle, this VOR. And then you had from there you had a star, and you had transitions from Atuma, Moram, and Relta. Now, after the ICAO standardization, following the publication rules of ICAO, now we have 3 stars instead of 1. So they used to have like transitions from these points to the common fix and then the star, but nowadays they have 3 different ones, which is according to ICAO, and it's correct. The question is, does it help? Is it good the way it is? Now, I'm through with my presentation. I would be pleased if we could open a discussion on transitions.
Joseph, small question from Tristan, Amsterdam. I understand your presentation, understand the concept of transitions. You mentioned a clearance would be like cleared via IF RMP approach 09, but an ATCO for various reasons does not want to clear an aircraft for a transition and an approach. It might be a very long trajectory. You have to cross a large part of the airspace, and your traffic needs to be separated from other traffic. So is there a possibility to only clear for the trajectory of a transition with a clearance limit of the IF maybe?
You can clear whatever. Here, the standard would be we shown not an approach clearance. It is an expect, which does not mean it is a clearance. The clearance limit, in this case, is Allen, but you could choose another one with another clearance.
I see. There's an expect here. It can be whatever.
You could also say ANI2 cleared via Walter Rolls 3 Echo, descend flight level 70, clearance limit is CODA.
Yeah, I see.
You can say cleared to CODA via Walter Rolls 3 Echo, descend, expect. It does not mean having a transition leads to a situation where an ATCO has to clear the entire thing in once. He can set clearance limits wherever he thinks they're suitable and good. And of course, as I said, it's not shown here. You could connect an approach transition to this system from Allen. You could have several approach transitions, like one leading from Allen to the runway, one leading a little further and even further. So in a very advanced ATM system, you could have the traffic separated out there before Walter or Darren already and clear the different aircraft to different approach transitions, granting separation for final approach. So it gives you options, but it does not restrict you to stick to all the possibilities. You could choose whatever is suitable at this point in time. Any more comments, questions?
Yeah, Joseph, may I? Yeah, Yuri Novak speaking. If you maybe go to the page number 12, please. I would be very much interested if you describe, please, if I have the arrival coming from the north to the Point Kleber, and I would like to make 2 transitions from Point Kleber to the runway, one to the north downwind and one to the south downwind. The common intermediate fix would be LACOP. How would the clearance for the transition would be hurt?
You could say via Kleber 1 or via Kleber 2. What you could do is you have the Kleber 1 going this way, and you have the Kleber 2 going this way.
What kind of workload presents you if the pilot is on the arrival route before the Kleber and he already selected the Kleber 1 transition, but during the arrival phase, the controller said to him, disregard the Kleber 1, please continue via Kleber 2. Is any messing up during the arrival before reaching the transition with the FMS? Could be something wrong, or is it okay?
You see here, this is the page of the FMS where you select the approach, stars, and transitions. It's one button. So assume you have, besides Kleber and Rick, you have not Kleber, but Kleber 1 and 2 and Rick. So you're on Kleber 1, but you get the clearance Kleber 2. You just push the button, the line select key 3 left, approach via, and change from Kleber 1 to Kleber 2. And the FMS switches from the south one to the north one, or the other way around.
Okay, yeah. But it should be done before reaching Kleber, right?
Well, if you do it after, you need to have a direct to a point on the other one, because, or a heading or whatever, to get this done. But this is not different from another arrival. Let's assume you are on a star, regardless which, and you get a reclearance to another star, which is possible, but it's not possible without giving you a direct to any point of the new star and then connect to the star. You can't do it out of the blue, which is today's daily business already.
Just one short question and then I'm finished. If the point Susan would be another initial approach fix from arrival from the south, and we have a transition Kleber 2, which is going through Susan, is it going to be some misunderstanding on the picture that we have two initial approach fixes in one transition, like Kleber and Susan, but it's common from one?
No problem.
No problem. Okay.
No, you can have, for example, you can have even Aline as one, IAF, and Gary as one, and Susan as one. If, as you can see in the coding table, you just add another approach transition, and you can have as many approach transitions as you like, and they can have common points. The name of the approach transition is the first point.
From Eurocontrol, do you hear me? Yeah. I have a question regarding the previous slide, slide 13.
Did you hear, Beat?
Yeah, he said a question about slide 13.
Why is there PVS1 in the clearance?
He was asking what PVS1 in the clearance means.
This is just the call sign of the aircraft.
Yeah, please, Joseph, it's Charlie again.
Yeah, Charlie.
Is it fair to say that the Americans tend to use the ARINC 424 coding for their use of these procedures, whereas here in Europe we are tending to use the term transition, and it's covering different elements in different states? You know, there's a commonality of the ARINC 424 en route transition, the common, and then the approach transition, and how it's cleared, as opposed to here in Europe where we're using different states are using transitions to cover different parts of that operation. Is that fair to say?
Yes, absolutely. And this is why I'm asking or suggesting we need an international standard. It's easier for pilots, especially those traveling worldwide, like myself, to hear from an ATCO and see on the chart more or less the same concept, which is not the case.
Okay, and that common standard could only come from ICAO adopting effectively ARINC 424 coding techniques.
Whatever they come up with, but they should come up with something that is a reference for those publishing and a reference for those working with it.
Okay, so if I may be so bold as to ask the chairman of the IFBB,
how dare you?
How far down the line, in reality, are we, or how far away from achieving that in Annex 11, Beat?
What I can tell you, Charlie, is that we have the task actually on the panel, and Rick Farnworth has been named volunteer to be the champion of the task. He was working on it for a while. He was also gathering input from within Eurocontrol at some point. How mature his paper is at this time, I don't know, to be perfectly honest. But also the whole activities in the panel are pretty much on hold. Well, not in the background. I mean, there's still work going on, but the meetings don't happen. I'm not positive. I don't think we will have another meeting this year. Probably the next one we will have is in spring 21. It's ongoing. As you know yourself from your work in the SASP, and sometimes panels or ICAO in general tends to make things a little bit overly complicated and try to solve more than is there to solve. So, and that delays the tasks a little bit. It is ongoing. Whether at what date it'll come into Annex 11, I'm not the right one to ask.
Yeah, but if you look at the practice we have out there, what the Canadians and the Americans are doing is working in practice. It's very complex airports, very complex systems, and their concept of using it, whether it's the smartest way you can do it or not, I don't know. But the way they're doing it is quite clever and it works in practice. Both sides works, like the pilot's workload and the controller's workload. It does not mean that we have worldwide and for ICAO to adopt it as it is, but it proves as a start point and a basis it is workable. And this is better and more than you have for other maybe new projects where you don't have any relation to practical use yet, and where you start at a green field bringing up something. Here you have like years of experience you can refer to. I think it's easier to work on this basis than to start all over on very clean sheet and try to get something done.
I think this is a very important point that you bring up, Joseph, because if we have a system that's used and that's actually commonly seen as useful and working, I don't think we should reinvent the wheel. It also risks that if we come up with the concept on ICAO level, then it's different from concepts that are already in place. It doesn't make sense. So I think in this regard, we could as well refer to the American colleagues and Canadian colleagues and say, okay, they have a working system and they use that concept of transitions. So why not clone it? Because if it works, then there's no need to fix it.
And please don't get me wrong, I'm not promoting any other change. What I'm trying to say is that there isn't the same commonality in Europe that we find is being applied in the States.
Yeah, fully understood. And that's right. We need to be careful. This is not continuing like that, because we often have these cases, right? The States do it this way and it works, and then Europe does it in a different way. It may be working as well, but it's not the same.
We have to think about the term transition, because even in this presentation, it is used for various purposes. The use of the term for en route transitions in SIDS and STARS, but also for approach transitions. So we have to think about terminology, because it seems there's a risk that we are going to use the term transitions for a lot of multiple purposes. On the diagram shown here on the slide, it is used actually for something what is really in ICAO terms called initial approach. It's the approach from clever to bold, and that's the initial approach. Here in the example, it's called also an approach transition, but we have to think about the proper use of the term transition, not use it for en route transitions and approach transitions. And sometimes we see even charts being published which are just plain stars, but they also have the term transition. They are called RNAV transition. So it needs to be cleaned up a little bit, the use of this term. Also interesting that you have used the diagrams of our Eurocontrol paper in the presentation. Thanks for that.
Get all of your comments, but what I get is that you have an issue with using the term transition, but I'm not a fan of using this term at all, not in ATC communication and not in charting. And this is the way it's done already when using these. You don't mention on a chart and you don't mention in ATC communication, RT communication, the term transition, because it's misleading. It can be confusing because the one talking about it, the one hearing it, might have another concept or another perception of what it is meant. If you look at the ATC clearance in our examples, you won't see the word transition anywhere, and that's for a purpose. You say you are cleared via, you are cleared a star via, but you never say transition, and that's for a good reason. But you need the term transition as a working term for those designing procedures and charting them, because they need to know what it is, because depending on what they design it for is the way the chart is being designed without mentioning transitions and the way it is coded by ARINC. So depending on the term you use in defining the procedure is the root type in ARINC you're using. But you never publish this term transition or speak about it if ATCOs and pilots talk to each other.
Are you Wang here from Netherlands? I was wondering which Eurocontrol paper are we talking about?
A paper that has been brought out by Rick Farnworth, and I used his graphics out of this paper. There's a newer paper where you see other graphics, like the one you see here is out of a newer presentation. So the approach transitions, I thought, are described better in this paper. The stars with transitions and SIDS with transitions are also better in the new presentation, but They are less simple, and I thought they were too complex to deal with in a 1-hour webinar. If we had 2 days, I would have certainly picked Rick's second paper regarding transitions, which is absolutely more detailed and very elaborate, but it was too big.
Do you have a title of that paper? I'm trying to find it.
The title of the paper is called What is a SID/STAR? What is a transition? The discussion paper can be found on the PBN portal under PBN on the flight deck, the actual studies that have been undertaken. You can equally send an email to either David or myself or to Rick Farnworth, and we can provide you that paper. It is on the portal.
Great, thank you, Charlie.
Other votes from the world?
Should you later come up with ideas, questions, comments, whatever, you can use this email address to contact us. I take it on me not to put all this onto Beat, but I will forward the stuff to Beat.
That's okay. So if there are no further votes, thank you very much for joining this one. I will edit it and then put it on the YouTube channel. It will take a bit of time, I guess, because I'm starting an advanced course next Monday, but I'm trying to be as quick as I can and then make it available. As I also said last time, this is a regular thing, maybe on a monthly basis or so. I'll come up with a topic at some point, release it through the usual channels, and then hope to see you again. And in the meantime, stay safe.
All right, thanks for watching. See you next time. Bye bye.